The objective for today's lesson is to determine whether the relation is a function and to find the domain and range and use the function notation. So a lot of this we've kind of already hit on as we've been progressing throughout this chapter, but I just want to go into it a little bit more in depth. And this is standard FIF1. Understand that a function from one set called the domain to the other set called the range assigns to each element of the domain exactly one element of the range. So that might at this point kind of sound like a little bit of Greek, but by the end of the lesson that should be very clear to you as to the meaning of that statement. So we've talked about what all the words are that mean the same thing as the x variable. We've got the independent, the x-axis, which is the horizontal axis, the domain. The words that mean the same as the y variable is the dependent, the y-axis, and the range. And when we're talking about a relation, it's just a pairing of numbers in one set called the domain. It's pairings of the x values with numbers in another set called the range. So we pair the numbers in the domain with those numbers in the range, and this is called a relation. So first of all, we need to identify the domain and the range. So we know the domain, we said, was the same as the x variable. So if each one of these numbers is an ordered pair, then my domain would be all of the values of x. It's the x values in the ordered pair. So I've got -2, 0, 4, and 5. That is my domain. I took the x value of that ordered pair, the x value of this ordered pair, the x value of that ordered pair, and lastly the x value of that ordered pair. So my range then would be all of the pairs, the y values of each pair. So if we listed the -2 for the domain, its corresponding part would be 0.5. Then we've got 2.5. And then we've got 6.5, and then we've got 2.5 again, but we've already listed it, so we only have to list it one time. So then it says represent that relation with a mapping diagram. So a mapping diagram is nothing more than two circles. And in the first circle, we're going to list all of the x values. And I like to always list mine in order, so -2, 0, 4, and 5, and then we're going to map them to their corresponding y values. So 0.5, 2.5, and 6.5. So you can see that -2 is paired with 0.5, so it gets mapped to 0.5. 0 gets mapped to its corresponding pair, 2.5. 4 gets mapped to its corresponding y value, which is 6.5, and then 5 gets mapped to 2.5. So we learned earlier in this chapter that a relation is a function, or something, anything is a function if each input is paired with only one output. So the input -2 is only paired with one output. The input x is only paired with one output. The input 4 is only paired with one output. And the input 5 is only paired with one output. So yes, this is a function. So now what we need to do is I would like for you to pause the video and go ahead and try the bottom one on your own now that you've seen how I've done this one. We'll give you a second to do that. Okay, so the domain, once again, is all of my x values. And my range, then, is all of the y values. Notice I listed the domain in order from least to greatest, and I'm going to do the same with my range. It's always a good indicator to me that my relation is not a function if there are more things in the range than there are in the domain. Because if there's more items in the range than in the domain, see, I only have 3 here and I've got 4 here, that means that one of these numbers must be paired with, one of the numbers of my domain must be paired with more than one number in the range in order for this to work. So go ahead and make your mapping. And we know that 6 gets paired with 5, 4 gets paired with 3, 6 gets paired again with 4, and 5 gets paired with 8. So now we can see that the 6 is paired with 2 different outputs. The input goes to 2 separate outputs, so we know that it is not a function. Okay. Another way to decide if a relation is a function is by using the vertical line test, which we've already talked about. So we can go ahead and plot these ordered pairs, go over -4, 1, 2, 3, 4, up 1, 2, put a point. Over -3, up 1, over 0, down to -2, go over -4, and down to -1. So I can already see right now that it's going to fail the vertical line test because right here, it passes through 2 separate points. And the way I can look at this, looking up here, -4 is paired with 2 different y values. If I was looking at the mapping, I would have -4 over here under the domain, and I would have -1 and 2 over here under the range, and it would be getting mapped to 2 different values. So it would not be a function. Not a function when one x is paired with 2 different y's. Okay, sorry about that. So is the relation a function? Use the vertical line test. So we've got this equation, -x² plus 3. So it's a little bit hard to see how to graph this right off the bat. So I find the easiest thing to do at this point in your Algebra 1 class is to go ahead and make a table. Let's plug in some values. Start with -2. If I plug in -2, then I'm going to have the -2 squared, but then I've got this negative outside of here that comes from right here. So -2 squared plus 3. Well, -2 squared is the same as -2 times -2, which is 4. Attach that negative to it, so -4 plus 3 is -1. Okay, let's do -1. -1 squared plus 3 becomes a -1 plus 3, which is 2. 0 squared plus 3 is 3. 1 squared acts much the same way as -1. 1 squared is 1. Attach that negative, so it's -1 plus 3, and I get 2. And +2 works the same way. I get -1. So now we can graph our ordered pairs. So I'm going to go over -2 down to -1. I'm going to go over -1 up 2. I'm going to go over 0 up 3. And then I can reflect across the line of symmetry, which you will learn about later this year. And just going to throw this out there. I knew that this would be a parabola. That's what the U-shaped graphs are called, this way or this way. I knew it should be a parabola because it is a quadratic function. There's that squared value in there. The other thing I knew is that it should be an upside down parabola because of this negative out here. So I always think negative people are frowning and they're sad, so that's how I remember. You know, if I used to put my little eyes here, this is a frowny face. Put my eyes, this one's a happy face. So if the x value is positive, it's a positive parabola. If the x value is negative, then it is a negative parabola. So now we need to see, now that we've got it graphed, is it going to pass the vertical line test? Oops, I moved the wrong thing. Oh, look what I did. There we go. I graphed it according to my vertical line rather than according to my graph. You guys wondering what in the world I was doing? Here we go. Now it's all fixed. So this vertical line here, I can run it through there and see. Is it going to pass through more than one point at any one time? And the answer is no. So this is a function. The parabola is a function. So if we were going to write it in words, I would say the relation is a function. Okay, so now I'm going to introduce you to what's called function notation. So up to this point, we've always said y is equal to -3x plus 1. And I remember when I got to college, seeing this. I probably had seen it somewhere along the way before then, but I forgotten it or something. But I remember seeing my professors write f of x everywhere. And I'm like, what is f of x? Well, f of x is nothing more than a fancy way of writing y. It's just called function notation. So you might be wondering, what's the purpose? Well, we notice that the f of x is replacing the y in this equation, and we read it as f of x. You've got the f, and then you've got the x. The f is not a variable. What the letter f stands for is the name of the function. Once again, not a variable. Function notation is to emphasize the fact that the function value, f of x, is depending, this right here, is depending on what we put in for x. F of x depends on the independent variable x. And we also use other letters such as g of x. So we've got the function g is depending on the independent variable x. Or we could use h of x. It doesn't really matter. It all means the same thing. So f of x is equal to negative 3x plus 1. So sometimes you might see this kind of problem. And it'll say evaluate for f of 3 and evaluate for f of 7. All that means is, notice I took my x out and I replaced it with a 3. So on this side of the equal sign, I've got to do the same thing. Wherever there's an x, I'm going to replace it with a 3. Evaluate this. Wherever there's an x, you're going to replace it now with 7. And then we can just evaluate. So f of 3, we know, is equal to negative 9 plus 1, which is negative 8. F of 7 is equal to negative 21 plus 1, so negative 20. Okay, so the function w of x equals 250x represents the number of words, w of x, that you can read in x minutes. How many words can you read in 8 minutes? So if w of x, where x represents how many words you can read in a minute, equals 250x, what is w of 8 equal to? So wherever we have an x, we're going to replace it with an 8. So 250 times 8 would be 0, 0, carry my 4, that's 16, 20. So 2,000, w of 8, in 8 minutes you can read 2,000 words if you read 250 words per minute. Okay, the domain of the function f of x is equal to negative 1/5 x plus 4, or negative 1.5, that's not 1/5. Negative 1.5x plus 4, and it says your domain, which we know is the x values, is 1, 2, 3, and 4, and it wants you to find the range. What is f of x? What is the y value, basically? What is f of x? So if I plug in 1 in place of x, negative 1.5 times 1 plus 4. Well, negative 1.5 times 1 is negative 1.5. And then if I add 4 to that, I get, what would that be, 2.5? I'm going to keep on going, write on down my chart. 1.5 times 2 plus 4, negative 1.5 times 3 plus 4, negative 1.5 times 3. And now I want to evaluate each one of those. And there we have it. So our range then, we need to write it out, would be negative 2, negative 0.5, 1, and 2.5 for this given domain. Okay, and then what I would like for you to do is go ahead and work out the ones that are circled in red. So you're going to have to pause the video at this point, and I want you to work out number 8, number 9, 12, 13, 14, 15, and then you get to choose if you want to do 16 or 17. I will be collecting these. They will be for a grade, so take your time and do your best. Have a good day.